All right, people. Good morning. So another day of office, and my sample here of the lichens that I have in a petri dish with a little bit of water is slowly showing signs of decay because there is too much of water around. The green is less, and the other part is more. So what I'm planning now is I had been observing this under the microscope for a few days now, and now I realize that other than protests, today I came with a new creature, some worms, huge worms in fact, and a tick and a worm. And what I am doing now is, see, what happens is with generally the process of microscope is that there is a light source which makes the light travel through the sample here, and then you see it. And this is a X-ray sort of a view. What I have tried here is a basic setup. I'd like to show it to you. What I have done is I've attached a torch, an LED torch, which is throwing light directly onto the slide. And what I'll see is the image caused by the reflected light. So it's not the light from this source coming through the sample like an X-ray, but a normal vision that we have, that the light falls on the substrate or the object and is reflected back, and we shall be viewing it from this point. So rather than where is the switch? Rather than this light, we shall be looking at this light. So I'll show you. Now it's off, and we see nothing for the time being. We see nothing, and when I put it on, we have the lights. So the light from the torch is falling on the sample, and this is reflected, and then we can see certain things. There you see. Now the benefit of it is that it doesn't give me a sort of an X-ray sort of a film, a picture, but a more true version of what we see generally. So let me get it a little aligned. Bear me for doing that. I'll soon fix it up on a, and then we can simply observe it. And you can see some protists already, some protozoans in their true color, and there is a tick, as I'd said. Now, if it is in an X-ray, if it was in the normal light system, the image would have been a little darker. I'll show you how. It would have been like this. I've switched off the torch, and this light I'll put on, and what we'll see now is the generalized X-ray sort of a view. And okay, let's keep a remembering thought. And now what I'll do is I'll switch it off, switch this on, and now you see a more realistic picture of it, right? Now you also see some protozoans in their jelly-like color, in their white gelatinous forms. Obviously, the definition is only of the outline and all those bouncy lights, but nothing more. But the good part is that in this process, we can see some worms, and we can see their body organelles as well, very clearly, like this one here, which I had been observing for a while. And I find that the body structures are better defined in this shade, in this sort of a light system, compared to the X-ray sort, the traveling light, the traversing light. So now what I'll do is I will mount the mobile on this tripod, which I have sort of inclined by some tweaks, and then I'll fix it here, and we'll keep on observing things. So let me do that for a while. Well, these are obviously we have microscopes these days which have a better lighting system, and they also provide us with this see-through and this reflective light arrangement. But then, uh, you see, I realize the fun in doing things my own way. So this gives me a better sense of involving in this whole process. Okay, enough said. We'll now just align the camera. It'll be a little tricky to arrange it very aligned, but once it is done, we won't have to bother anything else. Give me a minute, please. Had it been a recorded program, I would have saved on some time. But being live, I need to spend a bit more. All right. So once again, what I've done here is attached a LED torch which is throwing the light at an oblique angle. The original light source of the microscope has been cut off so as to allow the light to fall on the sample or the object, get reflected through the eyepiece for us to observe, giving us a more realistic picture. So now we put the camera in alignment. Once we are done, things would be easy for us. It's just a matter of minutes. There it is. We just need to focus it a bit more. Now, doesn't it look like a moon? Okay, so now that we have this basic setup, let us probe into the world of this little water puddle. Remember, this is what we are seeing is through direct reflected light, and therefore the color would be real as we would have seen with a normal daylight. The views would be more realistic, not like an X-ray. And now we start searching for the first. Okay, now let me show you, there was a tick here. Presently, let me bring the focus to 4x. You see the protozoans. Lovely, aren't they? Gelatinous whitish mass. And I need to move the camera a bit more. Well, I'll do that later. Now look at this. Isn't this much appreciable to look at? There is this little worm. You can see the movement of the body organelles in that worm. We'll just close into the tip. Imagine this tick. Had it been through the normal light system, it would have been something different like this. And you can't make out the color differences. It'll be difficult. But with the microscope's light off and the reflective light, we see more colors. We see better definition of the color and the morphological shapes, the little designings on the body, the little patterns, and all those things, they become very apparent. So, the protozoans, let's focus on these creatures. Now, if you ask me the magnification, the objective is 4x. The objective is 4x. The eyepiece is 10x, that is 40x. 3 times magnification by the camera, that is about 120. That's about 120 times. Could be more. Now, I'll just let the camera settle on one small portion while I'll do some more. Okay, here, something interesting. You see that whitish jelly hanging, that worm thing? What we'll do is we'll try to follow the body of the worm. And then you can see the eggs. See the stomach, the intestine, and then the spines on the body, the eggs within the body, and it is doing some occupation with that little tick, which is already dead, of course. There are monkeys outside my home. Let them be. The sound you hear might be is of those monkeys around. Okay, you'll see the eggs. There, you may be able to focus on the eggs now. So this is what the benefit of reflected light microscopy is. There are some more worms of much miniature size wriggling next to this giant, comparatively at least 100 times magnified than the young ones here. What is okay? All right, I've just realized one more thing. This is an improvement. Okay, I'll explain it later, what I've realized. You see this light system, this reddishness in the side, the pinkish reflection? What is happening is the other eyepiece, which is here, the adjacent eyepiece, being a binocular microscope, there is this adjacent eyepiece which has been left uncovered, and since we are observing the reflective light, there is a two-way system. The light from the objective is being reflected to us, and the light from eyepiece is being reflected to the objective. So what I see is this reflection. My movements are also reflected. So when I close it, the picture becomes much clearer. So I'll have to close it by some means or the other. Let me find anything. This is another interesting observation. Let me see if this works, though it's quite opaque. No, it's not. It's not worthy. Oh, they will put here. I'll cover it with something else, and you keep enjoying this while I find some other thing to explore a bit more. We are having this tick in focus with a lot of other creatures around. Some hair samples which I had gathered, I had accidentally dropped them. Let me collect. Okay, now I'll find something to cover that other eyepiece so that we get a more appreciable view. I'll be right back. Yes, folks, I'm back with a small cover to wrap on this little eyepiece so as to prevent the reflection. And I hope it will work. It should. All right. I've also got my little mic to connect. Is it only me getting this sort of reflection? Oh, it must be also happening from this one. So this little thing that we have, I'll draw the curtains. I'll draw the curtains. There is a white streak of light from the top side, which I'll try to somehow rectify. So what we see here, another worm. Let's focus. Okay, we'll increase the magnification to 10x objective. See, the true color is being reflected. It's not the transversed or pierced color, but the true color of the object, the sample that we have. I'll go back to the 10x, 4x. Let's try to give some of these creatures in focus. Okay, we'll move off, search the worm again, where it has gone, and see if we can trace out more of its anatomy by this reflective light system. Must be somewhere around here. What are these? Oh, there's a tick. There's a small worm near the tick, and this bigger worm, this big worm, you can see the internal organ systems. It's just under the debris, so it's kind of shy for the time being. Soon it will be present. You see that little hookworm there, the spin worm, not hookworm, but a pinworm trying to dig into some flesh of that decaying tick. I'm looking forward to get a view of clear, undebrided view of this little worm behind the tick, because you can already see those eggs arranged in the body all along the alimentary canal. There's a large number of eggs. So the fecundity of this animal, you can just imagine. All right, probably it's coming out of the debris now. Imagine living in a life in a matrix where there is a three-dimensional array of organisms in high density, and you have all the ways to move up, down, left, right, forward, backward. In all possible dimensions you can move. And imagine the sort of hegemony all around you as you see in here. All right, wonderful sight it is, isn't it? Let's focus on these creatures. Look at them. How beautiful. How beautiful. Now, had it been the normal reflected light, reflective, piercing light, it would have been black and white, sort of like this. This is the microscope's backlight, which does give me a very brighter tail, but it doesn't give me a very true color perspective. But when I put off the microscope's light and let this torch's light, the reflective light come, I suddenly get a very rewarding experience. Not like an X-ray, but more like the real world. Let the worm come out of this debris, because I had observed its heartbeat as well. Okay, just bear with me as I align this camera a little bit. All right, won't take much long. I guess this is better. Yeah. All right. No, don't. I was tweaking the camera again. I shouldn't. Waiting for this worm to get out of the debris so that you could see the pulsation of its heart. Patience will reward us, friends. Just a little bit more. उत्तम पंखा चलाइए. ये खोल दो. So, do we find something? Not yet. Okay, let's move the slide a bit. Please come out in the open. I can't tell you how excited I am observing the architecture of this little worm, microscopic worm, which is gigantic in relation to its other folks in the sample. But then okay, let me again tweak the camera a bit, because probably the alignment is sort of slightly off the track. Do we find anything interesting? Nothing else but the three-dimensional matrix of this little soup, wherein the life forms are having their own ways of moving around. Isn't it awesome? Just look at this. Looks like an alien world. It sure is an alien world to us. I'm tweaking the camera again a bit. See, this is an experimental setup, so you'll have to cope up with me and bear this experimentations, these little tweakings that I do. No, it's not good. the reflection from the curtain walls. Being a reflective light system, I've realized I need to close in all other light sources. So that will be next mission. But for the time being, the mission is to see the heartbeats. Okay, so okay, let me show you the eggs in this creature. Probably you can make out the outlines of this little worm, and you can see the peristaltic movement within the body. And okay, let's go for a higher magnification here to see something more. So I'm going for a higher magnification from 4x objective to 10x objective, and see if we find anything better. Now we see the eggs more clear. Though the camera alignment has gone off the wire, off the track. It's loving this debris to hide. Okay, one more time. Where is our dear worm? Here. So now let's zoom on there. I'll need to draw those curtains also. There are 3 curtains in this room which are creating these reflections on the lens and is forming a part of the image, distorting the shape. Okay, now we'll just zoom in on this. See the eggs? I believe them to be the eggs. You realize the peristaltic motion in the body. There's a new worm next to it, smaller worm. Just imagine this sheer difference in size. This is for sure a pinworm, a nematode. The same architectural plan is magnified many folds to form this one. Oh, somebody liked my video. Thank you so very much. I'm encouraged. I'm extremely thankful and encouraged. Now, just for the sake of comparison, I'll go back to the other light source, that is microscope's light source. 1, 2, 3. This is what you see in the normal microscopic view, microscope's light view, and it's all dark. even if I increase the light intensity, the contrast increases, but the details of the color and say the on the surface markings are lost. We get more of an X-ray view. Now I'm putting it off in 3, 2, 1. Just see the difference. Do you agree that this is more realistic and more rewarding for observation? Okay, I'll just tweak the camera a bit more, because somehow I'm not able to get the focus very perfectly. Suddenly the alignment has gone off track. Suddenly, and certainly. See those eggs at the tip? Those little granules. This being a cavity slide and there being some debris, the worm has ventured in an oblique manner. Therefore, the alignments have been distorted, the magnification has gone a little off track, and with every fraction of the body, the focal distance has changed, causing a little bit of effort in focusing. Okay, so we'll try go back to the tick that we had here. There was, remember, a tick around, a small tick which was decaying and was attracting a lot of creatures to nourish themselves with. Another worm wriggling around. See, the details in this picture are relatively much rewarding than the normal X-ray sort of view from the normal microscopic light. You see on the left bottom corner these brownish things, these networks, the root systems of the rhizoids of certain lichens or mosses. Their color is so true. Then the color of this moss and little patch of green island is so true. It's not like a black and white contrasted one. So this reflective light microscopy does have its own rewards, and soon I'll improve upon ensuring the alignment, a better way to increase the light intensity. Oh, there's a lot of worms in this water sample. If you're just wondering what this sample is, I'll reveal that at the end of this video in a few minutes. We are already 38, almost 39th minute of the broadcast. I'll reveal that sample which I have here, and for the time being we just explore around. So what I'll do is, just for the sake of quick views, I'll go back to 4x magnification so that we get a more wider version of what we are looking. See, the true color system is so apparent. It's much reflective. Sorry, my hand hit it. It's much defined. There is the tick. Now we wouldn't have been able to make out this on the surface structuring It's like a scanning electrons view on a very, very, very primitive magnification. I have removed the mic. It's shaking as I move. Now, I believe you will agree with me when I say that the structural patterns on this stick are much defined here in this view than the piercing light view. Even the worm that we have, a small one here, between its tentacles, is also more realistic. The protozoans moving around, they are more real. This worm around, this is more clear, more better to observe. The color pattern is much defined. So soon I'll sort of develop this worm is glistening. Look at those ticks. Sorry, not those ticks, there's just one tick, and there are a lot of parasites feeding over it, the decaying matter. The worm has started moving again, this bigger worm. I'm just waiting for once it straightens its body so that we can get a better view. There is adequate water there. Zoom out. Oh, interesting. I'm tired of standing up for so long. This is at 4x. I'll again increase it slightly. See that peristaltic movement in the body? The alimentary canal is undergoing peristaltic movement by which it propels the food further down the canal and the digestive arrangements. This is the head region. This is the caudal part, the tail region, and you can see those eggs. So this is real life, non-destructive observation. This is quite fascinating. The oral end. I think I shall move the camera lightly. No, I shouldn't. Let it be. So we go back to the tick. Where was it? Thank you, Madhu Bhai. Long time to hear from you. So we move over to the lower magnification and just go back to the tick. There is one small pinworm on the left antenna clinging over it. So now guys, I'll remove my assembly and once again reveal it to you. Let me switch on the lights first. Let there be light, and there is light. So guys, I'll close in this telecast, but before I do so, I will reveal you what I've been doing. So this was the setup, a normal LED torch on a microscope with the original light source off, and the camera assembly was on this, and this was the sample that we had been observing. A little bit of lichen on having some water in a petri dish. This is the water sample that we had been observing. So, and this is having all those sorts of interplays within the sample. The next sample that I have here is some rotting syzygium fruits, and you already see there are certain life forms growing over it. We'll observe it soon enough. So for the time being, this was the setup that we were doing, and before I close, a little reward for you: the sunshine, clouds, and view of the small township of Moda in Uttarakhand. So thank you very much, and soon we shall come with something new now. Yes, one thing I was saying was the camera was mounted on this way, and this was laid open. So what was happening is that all the light that was gathered by this eyepiece was also being reflected back into this one, and we were getting those different infringence, those rings, those light pollution in this particular view. So my next target is to shut this down, close it off, so that there is least degree of least amount of light light pollution, and maybe we'll come across with some better views next time. So that all interplay was happening in this much little bit of water. And let me take out the slide and see if we can make out that little tick here. There is the tick. Okay, let me put my hands a little stabilized. It's very difficult. Getting a little dizzy, but then sort of out of focus. but I think you can make out that little tick there and that worm adjacent to it. All right, friends, thank you so very much. Till next time, have a wonderful time around this view. The township of Almora bids you a goodbye. Keep exploring, friends.